Good evening, children.
Good evening, ma'am.
Good evening, ma'am.
Good evening, ma'am.
Good evening,
Good
ma'am.
evening, children. Good evening. Yeah. So, in today's class, we'll learn how to simplify real numbers. That is, add two rationals, addition, subtraction, multiplication, division of rationals, of irrationals, and of a rational and irrational. So, putting it in simple words, we'll see how to simplify real numbers. So look at this situation. So here we have minus 7 root 5, root 5, and 11 root 5. Now we know that 5 is an imperfect square. 5 is not a perfect square. So the square root of 5 is an irrational number. The value of square root of 5 is a non-terminating, non-repeating decimal. So square root of 5 or root 5 is irrational. Now, what is minus 7 root 5? Minus 7 is rational because it's an integer. Minus 7 is rational because it's an integer. Root 5 is irrational. Now, minus 7 root 5 is the product of a rational and an irrational. Minus 7 root 5 is the product of a rational and an irrational. Now, so in minus 7 root 5, this is rational, this is irrational. But what about the value as a whole? What about the value of minus 7 root 5 as a whole? It is irrational, or it will be irrational, because this one, square root of 5, has a non-terminating, non-repeating decimal expansion. That value into minus 7. Okay, that value, that non-terminating, non-repeating value into minus 7 will also be a different non-terminating, non-repeating decimal, right? So the whole thing is irrational. The whole thing is irrational. Minus 7 root 5 is irrational. Minus 7 is rational because it's an integer. Square root of 5 is irrational because it is the square root of an imperfect square. 5 is not a perfect square. Now the product of this rational and irrational, as a whole, this is irrational because this one is a non-terminating, non-repeating decimal. Multiplied by minus 7 will be a different non-terminating, non-repeating decimal. So on the whole, minus 7 root 5 is irrational. So like this, you can judge an expression which is made up of a rational and irrational, or two rationals or two irrationals. So let's take another situation. Now, supposing you have 5 minus root 3. 5 minus root 3. 5 is rational because 5 is an integer. Okay, you can have this 5 by 4 also. Okay, so 5 by 4. is a rational number. Integer by integer is a rational number. 5 by 4 is a rational number. Square root of 3. 3 is not a perfect square, and hence square root of 3 is irrational. So this one has a non-terminating, non-repeating decimal expansion. 5 by 4 is rational. So this one is rational. This one is irrational. Now the difference of this rational and irrational, what will it be? Now, since this one is irrational, this one has a non-terminating, non-repeating decimal expansion. Now, this one is rational. This one has a non-terminating, that is 5 by 4 is actually a terminating decimal. You can have a situation where it is a non-terminating repeating decimal also. So when you find the difference of this irrational number and this rational number, the resultant, the difference will be a new non-terminating, non-repeating decimal. It will be a new non-terminating, non-repeating decimal. So the difference of a rational and irrational is irrational. Now let's take the product. Let's take the product of this irrational and irrational. So square root of 5 into square root of 5. Square root of 5 is irrational. So square root of 5 into square root of 5 is equal to square root of 5 into 5. Square root of 5 into square root of 5 is square root of 5 into 5. So now from 2 5s, 1 5 out, 1 5 out, right? So root 5 into root 5 is 5. This is irrational, but the product is rational, but not always. In this case, okay. Now supposing we have square root of 5 into square root of 3. Square root of 5, irrational. Square root of 3, irrational. And what about the product? Square root of 5 into 3, which is square root of 15. And this is irrational because 15 is not a perfect square. 15 is not a perfect square, and hence square root of 15 is an irrational number because the value of square root of 15 will be a non-terminating, non-repeating decimal. Children, I've shared my screen. It's visible, right? I didn't ask you.
Yes, ma'am.
Yes, ma'am.
Yeah. So not always will the product of two irrationals be rational. Not always will the product of two irrationals be rational. They may be rational or irrational. Okay, so like now when we again take root 3 into root 3. Root 3 into root 3 is root of 3 into 3. And from 2 3s, 1 3 out of the square root. So square root of 3 into square root of 3 is 3. Square root of 3 is irrational. The product of these two irrationals is rational. Because 3 is 3 by 1, integer by integer, is a rational number. Whereas square root of 2, which is irrational, into square root of 7, which is also irrational, the product is square root of 2 into 7, which is square root of 14. And 14 is an imperfect square. It is not a perfect square. And hence, a square root of 14 is an irrational number. Now, cube root of 5. Okay, why 5 always? Say cube root of 9 into cube root of 9 into cube root of 9. Okay. Now 9 is an imperfect cube. It's not a perfect cube. 9 is a perfect square. It's not a perfect cube. 9 is a perfect square. So square root of 9. 9 is a perfect square. So square root of 9 is rational. Because what is the value of square root of 9? 3. And 3 is 3 by 1. Integer by integer. Rational number. Square root of 9 the value is 3, which is 3 by 1, integer by integer, it's a rational number. Now this is cube root of 9. Cube root of 9 into cube root of 9 into cube root of 9. So 9 is not a perfect cube. So cube root of 9 is irrational. Now let's find the product. So it will be cube root of 9 into 9 into 9. Cube root of 9 into 9 into 9. So from 3 nines, 1 9 out of the cube root. From 3 nines, 1 9 out of the cube root. Right? 3 equal factors. So you can bring 1 out of the cube root, 9. So the product of cube root of 9, cube root of 9 and cube root of 9 is 9. And 9 is 9 by 1, integer by integer, rational number. So the product here is rational. Here, this is irrational. Cube root of 9 is irrational. But when it's multiplied with itself 3 times, the product is rational. Now we call such things surds. Okay, now when you have this square root symbol or cube root symbol or the fourth root symbol, expressions with these symbols are called surds. Expressions with these symbols, the square root, cube root, fourth root, fifth root, these symbols are called surds. Surds. And so we have terms here like surds and unlike surds. And we also have surds of the same order, different order. We'll see all that. Now we'll see what like surds are. Like we have like terms in algebra. In algebra, we have like terms. Like terms, 2x and 3x are like terms. And like terms, you can add or subtract like terms. You can add or subtract only like terms. If they're unlike, you cannot add or subtract them, but you can multiply or divide them. Like 2x and 3x. 2x and 3x are like terms. Okay, so you can add 5x. You can subtract 2x minus 3x minus x. Minus x. You can also multiply them. Anything, whether like or unlike, you can multiply, divide them. But addition, subtraction can be performed only with like terms. Unlike terms, supposing you have x plus 3y, it's x plus 3y. Cannot be simplified further. X plus 3y is x plus 3y. But if you have to multiply x and 3y, if you have to multiply, yeah, you can. 3xy. 3xy. Multiplication, division can be performed with both like and unlike terms. Addition, subtraction can be performed only with like terms. So minus 4x square y, minus 7x square y. They're like terms because they have the same literal factors. They have the same literal factors. Right? So they're like terms and you can simplify. You can add or subtract them. So on adding, you get minus 11x square y. So this, you can extend the same thing to real numbers while simplifying real numbers. So here you can see, now we'll come to this. So you see here minus 7 root 5, root 5, 11 root 5. Now these are like surds because you can see this factor here, root 5, root 5, root 5. The irrational factor is the same. The irrational factor, see this is the irrational factor. The irrational factor. Okay, root 5, root 5, root 5 is the same. So they're like surds. Like surds, with like surds, you can perform addition and subtraction. With like surds, you can perform addition and subtraction. Now, so these are like surds because they have the same irrational factor. Root 5, root 5, root 5. They have the same irrational factor and hence they're like surds. And surds, I told you, all this with square root, cube root, fourth root symbol. When you see the symbol, you can call them surds. Okay, so if you have to add them, you can see the connecting sign. I've used a plus sign. So here I've just separated the terms with a comma. So now you know they're like surds and you want to add them. So connect the terms with a plus sign. With a plus sign. So minus 7 root 5 plus root 5 plus 11 root 5. You can add them. So just like you add like terms, treat it as an x. Treat it as an x. Okay. So minus 7x plus x plus 11x. What's the result? Minus 7 plus 1, minus 6, minus 6 plus 11, 5. Okay, so 5x, right? 5 root 5. 5x, 5 root 5. It works exactly like you simplify like terms in algebra. Exactly the same. Just treat that irrational factor as an x or a y. So you don't have to show these. Yeah.
Cube root of 5 and square root of 5 like surds.
No, they're surds of different order. You cannot simplify them.
Okay, ma'am.
They're surds of different order. Different order. And so they're not like surds because their irrational factor is not the same. Their irrational factor is not the same. See here. Square root of 3 and cube root of 2 are unlike surds of different orders 2 and 3 respectively. Yeah, the irrational factor must exactly be the same. If one is square root of 5 and the other is cube root of 5, the irrational factor is not exactly the same. It's like trying to simplify 7x square and 7, okay, say some 17x cubed. You're saying xx. No, it's x square and x cube. They're different. They're unlike terms. 7x square and 17x cubed. They're not like terms. They're unlike terms. In the same way, 7 into square root of 5 and say some minus 3 into cube root of 5. They're not like surds. They're surds of different order. This is the irrational factor. The irrational factor is not the same. It's not the same. So you cannot add or subtract it. So just treat this as an x. Treat this as an x. I told you this step, it's just for me to explain. So you don't have to do this always. You can just write this answer straight away. You can just write this answer straight away. So it's like taking out common. It's like taking out root 5 common. We have root 5 everywhere, right? So like taking out root 5 common. And so we have minus 7. There's a 1 here. Like x meaning 1x, right? X means 1x. Similarly, root 5 means 1 root 5. The rational factor is 1. The rational factor is 1. So 1 minus 7 plus 1 plus 11. So when you simplify this, you get 5. So 5 root 5. 5 root 5. In the next one, minus 4 cube root of 7, cube root of 7, 7 cube root of 7. This is multiplication. See, like x square y. What is x square y? X square into y. X square into y. Similarly, minus 4 cube root of 7 means minus 4 into cube root of 7. So you can see that the irrational factor, cube root of 7, cube root of 7, cube root of 7, is the same. So they're like surds. You can add or subtract them. So see these signs, I've just used different operations to explain how it works. So here I've just separated the terms with a comma. Here we're just trying to understand that they're like surds. And I've just used a minus operator between these two and plus between these two. Just taken a situation like that. So if you were to simplify this, so cube root of 7 is common. So we have minus 4, minus 1 plus 7 in the bracket. Minus 4, minus 1 plus 7. See here, this minus 4, minus 1 plus 7 in the bracket. So minus 4, minus 1, minus 5 plus 7 is 2. So 2 cube root of 7. So you can write it straight away. You don't have to show this one. So minus 4, minus 1, minus 4, minus 1, minus 5. Minus 5 plus 7, minus 5 plus 7, 2. 2 cube root 7, cube root of 7. So just treat this as a y or x. So it's like minus 4y minus y plus 7y. What's the result? 2y. And what is y here? 2 cube root of 7. As simple as that. And the next one, minus 8 fifth root of 2, 5 fifth root of 2, 10 fifth root of 2, 23 fifth root of 2 are like surds because they have the same irrational factor. They have the same irrational factor. This is the rational factor. Minus 8 is rational, 5 is rational, 10 is rational, 23 is rational. Rational can be anything. The irrational factor, like and like terms, see 7x square and 9 minus 9x square. The literal factors must be the same. The numerical factor can be anything. 7 minus 9, that can be anything. The letters, the literal factors must be the same. The same way here, the irrational factor must be the same. Okay, so I've just connected these two with a minus sign, these two with a plus sign, and these two again with a minus sign. So how do we simplify this? Yeah. So minus 8, minus 5, minus 13, minus 13 plus 10, minus 3, minus 3, minus 23, minus 26, fifth root of 2. Yeah, class, raise your hand if all of you understood this concept. Otherwise, please ask me your question. All right, yeah. Nice. Okay. So here also, these are like surds. These are like surds because they have the same irrational factor. The rational factor can be anything. The irrational factor, root 10, root 10, root 10, root 10. So they're like surds. And we're just trying to understand how to multiply. Okay, they don't have to be like to multiply. You can multiply any, whether they're like or unlike surds, you can multiply them. But we are learning how to multiply like surds. Okay, so how do we multiply? Multiply the rationals and multiply the irrationals. So multiply the rationals. See, because minus 5 root 10 means minus 5 into root 10. Like what is x, y? X into y. Similarly, minus 5 root 10 means minus 5 into root 10, into square root of 10. See, when you have xy into x square, y into x cube, it means what? X into y into x square into y, because x square y means x square into y into x cubed. It's multiplication everywhere. So it's minus 5 into root 10 into minus 3 into root 10. It's multiplication everywhere. So multiply the rationals. Minus 5, minus 3, 2 and 7. Minus 5, minus 3, 2 and 7. Multiply them. And then multiply the irrationals. Root 10, root 10, root 10, root 10. This is how we always multiply. In the case of, meaning in algebra also. See, when you have to multiply this, so you multiply x square and x cube, and then you multiply y and y. And here we say bases are same and it's multiplication. So add the powers, 2 plus 3, 5. Then y, 1 plus 1, 2. So like that here, collect the rationals, collect the irrationals and multiply them. Multiply the rationals, multiply the irrationals. So this product is 210. And here it will be square root of 4 tenths under the square root. So from these two tens, 110 out of the square root. From these two tens, 110 out of the square root. And this is the product. So all these were irrationals. This is an irrational, 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 irrational. The product is rational. The product is rational. The product of two irrationals may be irrational also. Like root 2 is irrational and 3 root 3 is irrational. Now the product 3 root 6 is also irrational. Is also irrational. Now see how to multiply this one. So minus 2 into 3 into 4 into 3 into 4. And then cube root of 5 4 times. So this product is minus 24. And here cube root of 4 5s under the cube root symbol. 4 5s. 1, 2, 3, 4. Under the 4 5s under the cube root symbol. So from 3 5s, 1 5 out of the cube root. This is minus 24. From these 3 5s, 1 5 out of the cube root. Then that fourth 5, no, that last 5 remains under the cube root. So cube root of 5. Minus 24. From these 3 5s, 1 5 out of the cube root. And this 5, the last one, remains under the cube root. So the product is minus 120 cube root of 5. Minus 120 cube root of 5. Now to divide, you can see here, this one gets cancelled. These get cancelled. 5 by 10 is 1 by 2. So unlike surds, these are unlike surds. They're unlike because you have 5 here, 7 here, 10 here, but they have the same order too. The same order. Everything is square root. But they're unlike because the irrational factor is different. No, here the factor is root 5. Here it is root 7. Here it's root 10. They're not like, they're unlike. But they have the same order too. Everything is like square root. Order is 2 everywhere. But they're not like. Because the irrational factor doesn't sound the same, no? How do we understand if terms are like terms? The literal factors must have the same sound. X square y. And even if you have y x square, you can still read it as x square y. X square y, x square y. So these are unlike surds. Because the irrational part, the irrational factor is different. This is square root of 5. This is square root of 7. This is square root of 10. So you cannot add or subtract them. But you can multiply them. You can multiply. So to multiply, see. 3 into 2. 3 into 2 is 6 and this minus sign, so minus 6. 3 into 2, 6 and minus 6, minus 6. And since everywhere the order is 2, you can put all the numbers under the square root symbol and multiply them. So square root of 5 into 7 into 10. 5 into 7 into 10. Now, you can break down 10 into its prime factors. 2 into 5. Now from 2 5s, 1 5 comes out of the square root. And then there's only 1 7 and only 1 2. So they remain under the square root. And 7 2s are 14. So the product is minus 30 square root of 14. So you can just do it when you just look at this, multiply the rationals. So it's 3 2s are 6. 3 2s are 6. And there's a minus sign here, so minus. And under the square root, we have 5, 7, and 10. 5, because everything has the same order, 2. So you can put all the numbers under the square root. Okay, 7 and 10. Then minus 6 square root of, if possible, break down the numbers into their prime factors. So here we have 5 into 2 minus 6. From 2 5s, 1 5 out of the square root. But 7 and 2, they don't have a pair, so they remain under the square root. 7 2s are 14. So the product is minus 30 root 14. Here also they are unlike surds, but of the same order too. They are unlike. The irrational factor is different. Square root of 15 is square root of 35. So you cannot add or subtract them. You cannot add, you cannot subtract them. You can multiply or divide them. You cannot add or subtract them, meaning through addition and subtraction, you cannot simplify them any further. You can just connect them with a plus sign and leave it there, or connect them with a minus sign and leave it like that. You cannot simplify them further. But with multiplication and division, you can make it look like a new number, a different number, a new number. Yeah, so if you have to divide, okay. So what is square root of 15? What is square root of 15? Square root of 3 into square root of 5. And square root of 35 is square root of 5 into square root of 7. So this gets cancelled. I think I've made a mistake in the slide. Instead of 35, I think I've put 5 here. Sorry. While typing, I've gone wrong. Let's do this. Just ignore the working here. Let's do it here. So we have minus 35 root 15 and 7 root 35. Okay. So 7 ones are 7 fives are. You can simplify that. So minus 5 root 15 is root 5 into root 3 divided by root 35 is root 7 into root 5. So this root 5 and root 5 gets cancelled. So we are left with minus 5 root 3 divided by root 7. Again, we have minus 35 root 15. Okay, root 15 can be written as root 5 into root 3 divided by 7 into square root of 35 is square root of 7 into square root of 5. Now, cancels. Minus 5 root 3. In the numerator, we have minus 5 root 3 by square root of 7 in the denominator. Yeah. This will just come to a little later. How to multiply unlike surds of different orders. Here, this was multiplication and division of surds of the same order. Same order too. Same order. If they have a different order, they're unlike surds of different order. Then how do you? I think we'll do it now. Otherwise. Okay. So these two surds are of different order. This is of order 2 because square root, and this is of order 3 because cube root. Okay, so now let's see how to multiply them. See, the thing is, if they were square root of 3 and square root of 2, you can put them under the square root, same square root, 3 into 2, and finish the product, square root of 6, finished. If they had the same order, so you can write both the numbers under the same order, square root or cube root. So if they were square root of 3 into square root of 2, then it is square root of 3 into 2, square root of 6, finished. Now this is square root, this is cube root. So now what will you do? Will you put a square root symbol or a cube root symbol? So the procedure to multiply them is different. You must bring them to the same order and then multiply. If they're of different order, you must bring them to the same order and then multiply. Like when fractions have different denominators, right? We call them unlike fractions. When fractions have different denominators, we call them unlike fractions. And you cannot add or subtract unlike fractions. To add or subtract unlike fractions, you have to make them like fractions. You'll have to bring them to the same denominator using LCM. You should find the LCM of the denominators and make the fractions like fractions using the LCM. And then you can add or subtract them. So like that here, they're of different order. You'll have to bring them to the same order and then you can multiply them or divide them, whatever. So let's see how to bring them to the same order. Now for that, we'll use the exponential notation because it's easier to, like explain and also to work. So now square root of 3 is written as 3 to the power 1 by 2. Square root of 3 is written as, so this is the exponential form. So there are two things here. So one is called the radical form. The other is the exponential form. Exponential form. So when you write them as surds, square root, cube root, fourth root, it is said to be in the radical form. Exponential form equivalent to them will be like this. For square root, it is to the power 1 by 2. Cube root to the power 1 by 3. Fourth root to the power 1 by 4, and so on. So square root of 3 in the exponential form is written as 3 raised to the power 1 by 2, not 3 to the power 2. 3 to the power 1 by 2. 2 to the power 1 by 3. That cube root symbol becomes 1 by 3. This is the base. This becomes the base. So when you write in the exponential form, you need to write two things, base and the power. When you write in the exponential form, you need to write two things, base and power. So what you see here is the base. The power is this one. This one becomes the power. So square root meaning to the power 1 by 2. Cube root to the power 1 by 3. This is the base. 3 is the base. 2 is the base. So 3 to the power 1 by 2 because square root. And for cube root, it is to the power 1 by 3 and the base is 2. Am I clear, children?
Yes, ma'am.
Okay.
Yes, ma'am. Yes, ma'am.
Okay. All right. So now look at the powers 1 by 2, 1 by 3. 1 by 2, 1 by 3. So they have different denominators, right? We'll have to bring them to the same denominator. So what's the LCM of 2 and 3? 6. So you need to bring 1 by 2, this fraction 1 by 2, to denominator 6. So you'll have to multiply and divide by 3. Write an equivalent fraction into 2 to the power 1 by 3 into 2 by 2. So that gives us 3 to the power 3 by 6 into 2 to the power 2 by 6. After writing the surds in the exponential form, you know that they have different denominators because they are surds of different order. So they will have different denominators. The fractions in the powers, they have different denominators. You will have to bring them to the same denominator using LCM. So you understand this. LCM of 2 and 3, not the base 2 and 3 children, the power, which is the fraction 1 by 2, 1 by 3. There, the denominators are 2 and 3. LCM is 6. So bring them to bring both the fractions, both the powers 1 by 2 and 1 by 3 to denominator 6. Okay. Now 3 to the power, write 3 by 6 as 3 into 1 by 6. Write 3 by 6 as 3 into 1 by 6. And write the power 2 by 6 as 2 into 1 by 6. That's the next step. Now, this is nothing but 3 cubed the whole power 1 by 6 into 2 square the whole power 1 by 6. Now, 3 cubed is 27. And to the power 1 by 6 means the 6th root of 27. Or you can also do it like this. So 3 cubed is 27 to the power 1 by 6 into 2 squared is 4 to the power 1 by 6. And you know this law of exponents, right? When the bases are different, but they're raised to the same power, you can multiply the bases and raise them to the same power. A to the power m into b to the power m is equal to a into b, the whole power m. When the bases are different, but the powers are the same, multiply the bases and raise it to the same power. So 27, 4. Bases are different. Bases are different. But the power is the same, 1 by 6. So multiply the bases and raise it to the same power, 1 by 6. So now this is nothing but 108 to the power 1 by 6, or the 6th root of 108. This is the product. This is the product. 6th root of 108. Understood, children?
Yes, ma'am.
Yeah. Yeah. Yeah, try to work these. I'll give you 10 minutes time to do this. 1 minute. Have you completed the notes so far?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Yeah, then you can. Yeah. Just you just need to take down these. I'll share these images. Leave some space for this, children. See here, you need to write this one. 1, 2, this one, 3, 4. That's it. That's all. This was just for understanding. You don't have to write down all this. Anyways, we're going to use all these operations when we solve questions. So you don't have to make a note of all this. Yeah, so this one, I'm coming again from the beginning. This one, 1, 2, 3, and 4. Just leave sufficient space for this one. and start working this. Yeah, solve this one, Shri. Probably if you're using a long notebook, 2 sides should do. 2 sides of a long notebook should do. Yeah, I'll come back in 10 minutes. Please try. Clear with my instructions, all of you?
Yes, ma'am. Yes, ma'am.
All of you, please work. Yeah, shall we see the answers, children? Have you completed? Shall we see the answers, children? Please respond.
No, ma'am, I'm still working on it.
Okay. Okay. Okay, let's see the answers to the first 5 questions. Yes, hi, Smriti. What is root 11 plus 3 root 11?
4 root 11.
Very good. Shreya, next one. Aishwarya.
Ma'am, I've got the answer. 5, no, minus 1 root 7 and plus 2 root 5.
Very good. Yes. This cannot be simplified any further, right?
Yes, ma'am.
Yeah. Correct, Shreya. Minus 7, minus square root of 7 plus 2 root 5. Very good. Surya, next one. Aishwarya. Lakshana.
Ma'am, 84 root 5.
84 root 5. Okay. 2 3 are 6, 6 7s are 42, 42 to 84 root 5. Correct. 84 root 5. Because 2 into 3 is 6. Root 7 into root 7 is 7. Root 7 into root 7 is root of 7 into 7. Right? So from 2 sevens, 1 7 out of the square root. So 7. Root 7 into root 7 is 7. So 2 3s are 6. Root 7 into root 7 is 7. Now 6 7s are 42. 42 into 2, 84. Root 5. 84 and root 5 you cannot multiply. 84 into root 5 is 84 root 5. Correct. 84 root 5. Next one, Yarni.
Ma'am, I got the answer is 11 root 3, ma'am.
11 root 3, yeah? Okay. So 3, 7. 7 and minus 6, 1 and minus 1. Yeah, 11 root 3, correct. Because this is 3 root 3, 7 root 3. Here also minus 7 root 3. So 11 root 3, correct. 11 root 3. 3 plus 4, 7. 7 plus 11, 18. 18 minus 6, 12. 12 minus 1, there's a 1 here. 12 minus 1, 11. 11 root 3. Harsha? Okay. So this one will be 5 root 2 plus 2 root 2 is 7 root 2. And into 3 root 5, into 3 root 5, which is 7 3s are 21. Root 2 into root 5 is root of 2 into 5, which is 10. 21 root 10. Okay, I'll just give you a few more minutes. Please complete.
Ma'am, I couldn't understand the fifth question, ma'am.
Fifth, huh? Okay. 5?
Yes, ma'am, 5.
Okay. So these are like surds, no? 5 plus 2, 7. 7 root 2, correct?
Yes, ma'am.
And into 3 root 5. Now multiplication can be performed even with unlike surds.
Okay,
So
ma'am,
now,
okay.
yeah,
Understood.
7 3s are 21.
And 2 5s are 10. Okay, ma'am. Thank you, ma'am.
10. Somebody's mic is enabled. Disable your mic. All right. Yeah, so Surya, what's the answer for the 13th one?
Ma'am, 3 root 2 7, ma'am.
The 13th one. 13th one.
sorry. No, I told the answer for 6th one.
Yeah, I know that. Yeah, I got that. Yes. 13th one.
13th one, actually, I'm working it.
Okay, you can tell me now.
Oh, yes, ma'am.
Hmm.
3.
3, yeah? No? Shreya?
27 root 125.
No. Aishwarya?
5.
5. Steps?
Mom, so it'll be root 3 by 5 into 5 into 5. So when we take it out, it'll
Root
be,
3. Where is root 3 here?
no, Mom, I said cube. Sorry, cube root
Okay. Cube root?
of 5 into 5 into 5.
Cube root of, yeah, cube root of 5 into 5 into 5. Okay.
It'll be 5.
Correct. So from 3 equal factors, 1 out of the cube root. So it's 5. Cube root of 5 into cube root of 5 into cube root of 5 is cube root of 5 into 5 into 5. So from 3 equal factors, 1 out of the cube root. So the value of this expression is 5. What about this one? Anyone can answer? What's the answer for the 14th one?
Cube root of 5. 3 cube root of 5.
Correct. 3 cube root of 5. 3 cube root of 5. It's like 1 cube root of 5 plus 1 cube root of 5 plus 1 cube root of 5. So 1 plus 1, 2, 2 plus 1, 3. 3 cube root of 5. This cube root of 5 is like x. This is like x. X plus x plus x. What is x plus x plus x? 1x plus 1x plus 1x. 3x. 3x. So it is 3 and x is cube root of 5. So cube root of 5. So that's the difference between the sum and the product. The product here, see you have the same surd, cube root of 5 in both the cases. Here we multiply and here it is addition. So cube root of 5 into cube root of 5 into cube root of 5 is cube root of 5 into 5 into 5 and the result is 5. While here it is 1 cube root of 5 plus 1 cube root of 5 plus 1 cube root of 5. So 1 plus 1, 2, 2 plus 1, 3, 3 cube root of 5. Yeah, and the 15th one, 4th root of 2 plus 4th root of 2. This is 4th root of 5. See, it is the terms are connected by a plus minus sign. So they have to be like surds. In order to add or subtract, they have to be like surds. That means they must have the same irrational factor. So 4th root of 2, 4th root of 2, same irrational factor. So it will be 1, it is 1 4th root of 2 plus 1 4th root of 2. So it is 2 4th root of 2. 4th root of 2 as it is. 1, the coefficient, the rational factor, 1, 1. 1 plus 1, 2. And here, 4th root of 5, 4th root of 5. Same rational factor, sorry, same irrational factor. So they are like surds. fourth root of 5, fourth root of 5. Same irrational factor. So they are like surds. You can subtract. Now this is 1 fourth root of 5 and minus 7 fourth root of 5. So plus 1 minus 7 is minus 6. Minus 6 fourth root of 5. Sharing these images on WhatsApp. So if you have to do some corrections, if you're wrong in a few places, please repeat the whole thing. Practice once again. Because this forms the, the very basics of simplification. So only if you're good with this, the rest of the chapter is going to be very easy. If we have trouble in calculating here, trouble in understanding, not trouble actually, you need to practice to, understand better. You can ask me doubts. I'll just give you some time to go through this. You can ask me if it's not clear, please ask me. And then you need to practice. So be good at this. Then the rest of the chapter is very easy.
Ma'am,
Yeah.
ma'am, in the second question, it is like 2 root 5 minus 7. It has to be 2 root 5 minus root 7.
Question number?
Second question. The last
Second
step.
question. Second question.
The last step.
Let me just check. 2 root 7 minus 2 minus 3 root 7 plus 5. Oh, this root I've forgotten to type, correct?
Yes.
Oh, thank you. Thank you. Yeah. Typing mistake. Okay. Thank you. Yeah, 7 to 11 we did not discuss. Please check your answers. On it.
Ma'am, just a second. I'm just checking the 15th one, please. Thank you. Okay, ma'am. It's fine.
Yeah. Yeah. Okay, so the heading is you need to solve using an identity if possible. All right. So the first one is 2 root 3 minus 5. Sorry, 2 root 3 minus root 5 into 2 root 3 minus root 5. So it's like a minus b into a minus b. It's of the form a minus b into a minus b, which is a minus b the whole square. So it is, don't write 2 root 3 minus root 5 the whole square. So this is of the form a minus b the whole square, where a is 2 root 3 and b is root 5. So how do you expand a minus b the whole square? A square, 2 root 3 the whole square, minus 2 into a into b. 2 into, this is a and this is b. 2 into a into b. Then plus b square, plus this is b square. So now 2 root 3 the whole square means 2 root 3 into 2 root 3. 2 root 3 the whole square means 2 root 3 into 2 root 3. Now 2 into 2, 4. See, when you're multiplying, you don't have to check whether they're like or unlike. You can just multiply. Only when you have to add or subtract, you'll have to make sure that they are like surds. Multiplication, just do. So multiply the rationals, 2 2s are 4. Multiply the irrationals, root 3 into root 3 is root of 3 into 3. Root 3 into root 3 is what? Root of 3 into 3, which is 3. Root 3 into root 3 is 3. Root 5 into root 5, 5. Root 7 into root 7, 7. Two into 2, 4. Root 3 into root 3 is 3. And 4 3s are 12. So this one is 12, children. 2 root 3, the whole square is 12. 2 into 2, 4. Root 3 into root 3, 3. And 4 3s are 12. Minus 2 2s are 4. Root 3 into root 5. Both are surds of the same order. So root 3, square root of 3, square root of 5 can be written as square root of 3 into 5. square root of 3 into 5. So square root of 15. Square root of 15. So 2 into 2 is 4. 4 root 15. Plus root 5 the whole square. Root 5 the whole square is root 5 into root 5. So it is root of 5 into 5. Square root of 5 into 5. So from 2 5s, 1 5 out. So 5. Square root of 5 into square root of 5 is 5. Now 12 plus 5 is 17 minus 4 root 15. Because this is rational, this is irrational. You cannot simplify them. 4 root 15, they're not like surds. This one is not a surd at all. This is rational. This cannot be simplified further. Because when you have 4 root 15, if this was 17 root 15, then you can simplify. 17 root 15, then you can simplify. This you cannot simplify further. So 17 minus 4 root 15 is the answer. Tell me what is 3 root 3? What is the value of 3 root 3, the whole cube? What's the value of 3 root 3, the whole cubed?
One.
No.
$81.
81. No.
Mom, 27 cube root cube root 3.
27.
Cube root 3.
No. Three root 3, the whole cube.
Mom, is it
Yeah.
27 root 27?
27 root 27 is
27.
correct, but like if you give an answer, if you say the answer is 10 by 20, you're right, but what's the answer? 1 by 2, right? So it's like that.
Yes, ma'am.
Yeah. So you're saying 10 by 20. You're right, but I am expecting you to say 1 by 2. So 27 root 27 is right, but I want you to give the answer in the simplest form. So the value of 3 root 3 is
square 3.
27
Square 3.
square root of.
Square root of 3.
No. No. All right. So 3 square root of 3, the whole cube is nothing but 3 root 3. Root 3 meaning square root. 3 root 3 meaning square root of 3. If it's cube root, you have to say cube root. When you say root 3, it means square root of 3. If it is this one, we have to say cube root of 3. That's how it's pronounced. Cube root of 3. When we just say root 3, It's square root of 3. Okay. So 3, the whole cube is equal to 3 root 3 into 3 root 3 into 3 root 3. Now this is 3 into 3 into 3 into square root of 3 into 3 into 3. 3 into 3 into 3 into square root of 3 into 3 into 3. Now this is 27. And from these two 3's, 1 3 comes out of the square root. From these two 3's, 1 3 comes out of the square root. And this 3 remains under the square root. This 3 remains under the square root. So the answer is 81 root 3. 81 root 3. Three root 3 into 3 root 3 into 3 root 3. Multiply the rationals. 3 into 3, 9. 9 3s are 27. 27. Now you need to multiply the irrationals here. Square root of 3, square root of 3, square root of 3. They have the same order, no? So square root of 3 into 3 into 3. 27 into, from 2 3's, because they're under the square root. So from 2 equal factors, you can bring 1 out of the square root. So 1 3 comes out of the square root, but there's one more 3 that remains under the square root. So put that. This one is 81 root 3. The answer is 81 root 3. Okay, so now tell me what is 2 cube root of 5, the whole cube. Yeah. I'm giving you time to calculate. Once you get the answer, tell me.
40.
Come again.
40. No.
40.
Yes.
Okay. Hi, Smriti, is it?
No, ma'am, Lakshna.
Oh, Lakshana. Okay, okay. Okay. 40. Let's just wait for the others to process.
I'm also getting 40, ma'am.
40. Okay. Can you explain how, Shreya?
Just a second, ma'am. Just a second. So since it is since it's the whole cube, so you multiply it 3 times.
Correct.
Then 2 into 2 into 2 on one side, and cube root sign, and 5 into 5 into 5. So since it's cube root, 5 comes out, then 8 remains. 8 into 5 is 40.
Very good. Well explained. So 2 into 2 into 2 into cube root of 5 into 5 into 5. So 8 into 5, 40. Very good. Lakshana also. Good. See, we need to multiply 2 3 times and cube root of 5 3 times. Cube root of 5 3 times. So now this is 8. See, here it is not from 3 to 1 2 comes out. That's not under any radical sign. It's 2 into 2 into 2, which is 8. Here, cube root of 5 into cube root of 5 into cube root of 5. They have the same radical. So cube root of 5 into 5 into 5. Now, when the numbers are under the cube root, from 3 equal factors, we bring 1 out of the cube root. So 3 5s, 1 5 out. So 8 into 1 5 out, so 40. Yeah, you can just make a note of this. What was the one we took up earlier? 3 root 3 the whole cubed. Yeah. So this is 3 root 3 into 3 root 3 into 3 root 3, which is 3 into 3 into 3 into cube root of 3 into 3 into 3 is 27 into.
It is cube root of 3 into 3 into 3, right? So you've written square root.
No, this is different. This is the one I did before this. Where have I written square root?
Mom, you've written square root of 3 into 3 into 3. Right now, this question only.
This one is what we did first, no? This is square root of 3. 3 square root of 3, the whole cube.
Okay.
Yeah. Yeah, you can make a note of this, children. How to simplify or how to find the value of 3 root 3 the whole cubed, 2 cube root of 5 the whole cubed. Okay. So for the second one, we did the first one. Second one, you need to use the identity a plus b the whole square, because this is like a plus b into a plus b. So a plus b the whole square, which is a squared plus 2ab plus b squared. For the third one, a plus b into a minus b, a squared minus b squared. A squared minus b squared. A plus b into a minus b is a squared minus b squared. So I hope all of you have made a note of this. 1 and 2, what you see on the screen? 3 root 3 the whole cube and 2 cube root of 5 the whole cube.
Done, ma'am.
Okay. Yeah, now take down this 1, 2, 3. You will take the help from the slide and work it. 4, 5, 6, 7. You load yourself and we'll check the answers. So 1, 2, 3. Understand as you, I just explained them. For the first one, it's a minus b into a minus b, which is a minus b the whole square. Second one is a plus b into a plus b, so a plus b the whole square. And the third one is a plus b into a minus b, which is a square minus b square. Or you can make a note of the identities in case. Take a screenshot, and if you want to make a note of them, please write down. Let me do one thing. 1 second. Yeah, make a note of the identities.
Hello, ma'am. Ma'am, I think you have forgotten to written one identity.
Yeah, which one?
X plus A, X plus B is equal to X square plus A plus B, X plus A.
No, that's what we won't be using that here, so I've not mentioned that.
Okay.
Yeah.
Noted, ma'am.
Yeah, good, good. Yes. So you can say 2 root 3, 2 root 3, A, square root of 5, square root of 5. So B, minus, minus. So it is A minus B the whole square. You have the same expression in both the brackets. A minus B into A minus B is A minus B the whole square. And to expand A minus B the whole square, it is A square minus 2AB plus B square, where A is 2 root 3 and B is root 5. So now use this one to expand. A square, 2 root 3 the whole square, minus 2AB, minus 2 into, this is A and this is B, 2AB, plus B square. So plus root 5 the whole square. Now 2 root 3 the whole square is 2 root 3 into 2 root 3. 2 root 3 the whole square is 2 root 3 into 2 root 3. 2 2s are 4. Root 3 into root 3 is 3. Root 3 into root 3 is 3. Root of 3 into 3. From 2 3s, 1 3 out. So 3. So 4 into 3 is 12. 4 into 3, 12. And this is 2 to the 4. Root 3 into root 5 is root 15. Root 5 into root 5 is 5. And now 12 plus 5 is 17. So 17 minus 4 root 15. Finished?
Ma'am, are we supposed to take the screenshot?
No. I'm waiting for you to finish writing now.
Oh.
I told you, no? I told you 1, 2, and 3, you will be writing it now with the help of the slides. 4, 5, 6, 7, you will be doing it yourself. I'll give you time and then we'll discuss the answers. You were supposed to leave 2 pages, 2 sides to write that introduction, the theory part. And after that, we had started working. Were you writing in your book all the way, Shreya?
Yes, ma'am, but this one I was not sure.
Okay. Others finished? Okay. Yeah. Yeah, please write this one also. A plus B into A plus B is A plus B the whole square. That expands to A square plus 2AB plus B square. Complete this, write down. So here the 2 root 2 the whole square is 2 root 2 into 2 root 2. 2 root 2 the whole square. So 2 into 2 is 4. And square root of 2 into square root of 2 is square root of 2 into 2, which is 2. Square root of 2 into 2. So from 2 equal factors, 1 out of the square root. So 4 into 2, which is 8. That's what you see here, 8. And this one is 2 into 2, 4. 4 sevens are 28. 28 root 2. 28 root 2. 7 squared, 49. 8 and 49 is 57. plus 28 root 2.
Completed.
Yeah.
Done, ma'am.
All right. This is the next one. Work it. See, in the first and second one, this is irrational. This expression is irrational. The product of this irrational expression with itself is also irrational. This expression is irrational because this one is irrational, non-terminating, non-repeating. This one is also non-terminating, non-repeating. So the difference will be a new non-terminating, non-repeating decimal. This expression is irrational. The product of this irrational with itself is also irrational. You can see here 17 minus 4 root 15 is irrational. Same thing here. The product of this irrational with itself is also irrational. But here you see the third one, this is irrational. This is also irrational. But their product is rational. 62. Irrational, irrational. They are two different irrational expressions, not the same. They are two different irrational expressions of the form a plus b and a minus b. And you see their product is rational. 62 is rational. Yeah, right on.
Please write in.
Completed?
Yes, ma'am.
Okay, so if you finished 1, 2, and 3 children, you're ready for the test. All of us have completed the third one?
Yes, ma'am.
All right. Yeah. Try 4, 5, and 6. Question number 7, you cannot use any identity. So do the regular multiplication. The first term, multiply the first term with the second bracket. That is, multiply the first term in the first bracket with the second bracket, and the second term in the first bracket with the second bracket. So for the 7th one, no formula.
Ma'am, for the sixth one also we can't use any identity.
6th also. Oh, I didn't. Yeah, you're right, Sai Smriti. I didn't notice that. Right. I don't know if it's Sai Smriti or Lakshana. Who was that?
Sai Smriti.
Okay. Yeah, you're right. So this also first term of the first bracket into the second bracket. Second term into the second bracket. Correct. Done, children?
No, ma'am, not yet.
Okay. Has anyone completed?
Yes, ma'am.
Okay. So what's the answer of the fourth one? Read the final answer of the fourth one.
40
Ma'am, I'm sorry, Smriti, can I
minus 24 root 12.
Again,
48 minus 24 root 12.
48 minus 24 root 12. Okay. Same answer, all of you?
Yes, ma'am. Ma'am, I got
Okay.
a different one.
Ah,
96 minus 48 root 3.
okay. 96 minus 48 root 3. Okay, let's see. Correct. 96 minus 48 root 3. Okay. So a square minus 2ab plus b square. A minus b the whole square is a square minus 2ab plus b square. So now this is 6 into 6, 36. Root 2 into root 2, 2. 2 6 are 12. 12 2s are 24. Square root of 2 into 6. Square root of 2 into square root of 6 is square root of 2 into 6. And here 2 2s are 4. Root 6 into root 6 is 6. 36 into 2, 72. 4 6 are 24. And 72 plus 24 is 96. And here the middle term, you can factorize 6 further. So whenever you can break down a number, if it's a composite number, you can break it down and write it as a product of its prime factors. So do that. 6 is 2 into 3. 6 is 2 into 3. So now you have 2 2s under the square root. So 1 2 comes out. So there's already 24 outside the square root. And now from these 2 2s, 1 2 comes out. And this 3 remains under the square root. There's only 1 3, right? It doesn't have a pair. So that remains under the square root. So this gives us 48 root 3. 48 root 3. And as I told you, 72 plus 24 is 96 minus 48 root 3. You cannot simplify this further, right? Yeah. Yeah, what's the answer for the next one?
14 minus 2 root 5.
Okay. Same answer, all of you?
Ma'am, I got a different one.
Yeah, what's it?
29 plus 6 root 6.
29 plus 6 root 6. And Smriti, what did you say? 14
Minus 2 root 5.
minus 2 root 5. Okay.
Ma'am, I also got a different answer, ma'am.
Different from these two.
Yeah,
Hmm.
it's actually 20 plus 6 root 6. That's what I got.
Okay. Now, did anyone say this answer? Or did anyone get this answer? What you see on the screen?
Ma'am, and Lakshna got it right.
You got this. Okay, Lakshmi. Fine. Good. So a plus b the whole square, which is a squared plus 2 into a into b plus b squared. Now 3 into 3 is 9. Root 3 into root 3 is 3. 2 3s are 6. Root 3 into root 2 is root 6. And root 2 into root 2 is 2. 9 3s are 27. And this 2. This is 6 root 6. 27 plus 2, 29 plus 6 root 6. Yeah, please ask me if you have a doubt. If you're able to make out your mistake and you're able to correct your mistake, fine. Otherwise, if you still don't understand, please ask me. Which is that part where you've gone wrong in calculation? Able to make out your mistake?
Yes, ma'am.
Okay. What's the answer for the next one?
Ma'am, 34 minus 14 root 5.
Correct. So here it's going to be like first term multiplied with the second bracket, second term multiplied with the second bracket. So this is the first step. This is the first step. 7 into 7, 49. 7 into root 5, 7 root 5 plus 7 root 5. Then minus 3 into 7 minus 21 root 5. Minus into my plus minus 3 root 5 into root 5. So 3 into root 5 is 5. So 15. Now 49 minus 15, 34. Plus 7 root 5 minus 21 root 5. They're like surds. They're like surds because they have the same irrational factor. Like surds. Plus 7 minus 21 is minus 14 root 5. Class, use the emoji. Raise your hand. Very good. Akshana, Aishwarya, Shriya, Saraswati, Surya, Yarni, and Harsha. Good. Yeah. So this is what we do with algebra also, right? If you'll have to multiply 3x plus y into, say,
Binomial by a binomial, ma'am.
correct. Product of a binomial with another binomial. 4 minus, say that's 2y. So 3x into the second bracket, 4 minus 2y, plus y into the second bracket, 4 minus 2y. That's what we do here also. Okay, next one. Yeah, I didn't ask you. What's the answer for the next one? I know response. Still to try, is it? Not completed the 7th one?
Yeah, ma'am.
Oh. Okay, but since it's time, we'll just see the answer. You can complete it later. So 2 root 6 multiplied with the second bracket minus root 5 multiplied with the second bracket. That's the first step. Now we'll multiply these two terms. 2 into 3, 6. Root 6 into root 5. Root of 6 into 5. Root 30. See, now we're not breaking down 6 as 2 into 3 because even if you break down, you'll have 1, 2, 1, 3 and 1, 5. It's not going to help because you need to have pairs of equal factors under the square root if you have to bring one of them out. So root 6, when you multiply root 6 and root 5, root 6 into root 5, it's root of 6 into 5. And if it's a composite number, we have to break it down into its prime factors. But we don't do that because 6 is 2 into 3. So that's going to be 1, 2, 1, 3 and 1, 5. All right. So anyways, no factor will come out of the square root. 1 second, children. Yeah. So 2 into 3, 6. Root 6 into root 5 is root 30. Next, 2 into 2. 2 into minus 2. Minus 4. And root 6 into root 6 is 6. Root 6 into root 6 is root of 6 into 6. So 2, 6, 1, 6 out of the square root. 2 root 6 into minus 2 root 6. 2 into minus 2 is minus 4 into root 6 into root 6 is 6. So the product is minus 24. Minus 24. Next, minus root 5 into 3 root 5. So root 5 into root 5 is 5. Minus 3 into 5, minus 15. Minus root 5 into 3 root 5. Root 5 into root 5 is 5. Into 3, 15. Minus 15. Minus 15. Minus root 5 into minus 2 root 6. So minus into minus plus. Minus into minus plus. This 2 here. And root 5 into root 6 is root of 5 into 6, which is root 30. Now minus 24 minus 15 is minus 39. And these two are like surds. They have the same irrational factor, root 30. So 6 plus 2, 8. 8 root 30. 6 plus 2, 8. 8 root 30 minus 39. Any questions, children?
No, ma'am.
No, ma'am.
All right, children. So that's it for today's session. Thank you so much. Good night. You may leave the call.
Thank you, ma'am. Good
Thank
night.
Thank you, children.
Thank you, ma'am.
Thank you, ma'am.
Thank you, children. Good night.
Ma'am, one more thing for that